So ladies and gentlemen, Mason here. I'm working on a burner, and today we're going to go over what I've been doing in this last week. So we can here see the burner house itself, and here is the burner. Last week I've been able to basically assemble the whole thing and weld the flange onto it, and this week I basically took the barrel that we have washed last week and added a bunch of stuff onto it. First of all, we have added the burner, so we have drilled out the holes to it. So and we basically bolted it into it. First, we use these little screws, these self-cutting metal screws. We will remove them later on in the tests, and we will replace them with bolts that are going to be welded on into the thing. Going to be portaining out, so we would just only need to put on a screw and that's it. We have also added this, as you can see, this rope here that acts as a gasket to seal out the gas coming back. So this way it is nicely and sealing evenly around the uneven edge. We have added this cool looking little adapter. This is there for a 3 clamp with the blower, because I have got very annoyed with the fact that basically I had to always cut the ceiling or the sealant so that I can remove it. So I have designed this and added this here so that we can remove it quickly. So I've added multiple ports to the thing. First we'll go to the most obvious one, which is this, which is the chimney, which will basically be the exhaust for the whole thing. And here I have also added, this is just the adapter, the chimney will be 1 meter tall. Here I have added this bolt with this thing. This is basically exhaust paste that is gas tight and is basically able to withstand the heat. So that is sealing there around this lead, which is the thermocouple, as well as this one. It's basically the same thing. They are thermocouples. One is just inside about 20-ish millimeters. The other one is basically in the middle. You can see it there. It's flush. The tip is basically out and exposed to the gas, so that we will be able to measure the exhaust gas. Here the gas above the burners to kind of know that if it is going or what's happening inside. As well as added this other port here, that is the pressure 1 or P1. This is the T1, this is T2 there, and this is the P1 or pressure 1. This is basically a bolt, same thing as there. We'll have to add some sealant around the thread, but it is going to be alright. And this brake line copper pipe is hot soldered with silver soldered into the bolt. This is basically for us, this is the band up here that to have this water trap when the air can basically cool down in this copper tube, but the water will basically drip down and not go into the pressure sensor. With this we will be able to detect quick events like blow off, flashback, all that bullshit. Also we have the thermocouple leads there. So going forward, here it is the blower, and basically this didn't change too much except this. I've glued this onto it. Here's the 3 clamp. This will be basically clamped with the identical part on the burner. So that's it. The other part of the work was basically figuring out what I was doing with the thermocouples. So it was a lot of code-based integration and all that bullshit. So debugging this bitch, because we have this thermocouple here. With the STM32 it was very hard to get right, and I was sucking cock for it with it for 2 days. Probably like 5 to 7 hours went into this totally. The problem was that the thing was hooked up. This is a Mark 6675. It was properly hooked up, and it was not willing to work because I have set up the CS pin, which is the middle one, which doesn't matter, to receive only master, which was not the case. It required a full duplex master, and because of that it didn't work until day 2, about 6 hours ish in total. So then I have did the same thing with this, which is this bigger thing here, bigger thermocouple, made them both of them work. And then after that, I have started to disassemble this big bunch of fucking shit and made it into a more nice looking little neat board, which is this. And I think this looks better than that, right? So we will be able to use this. This is a motor controller as for the stepper motor, which is basically on the ground here. And I've disassembled it with the air screw, so that we will be able to put this sliding rail pot meter onto it, so that we will be able to have a feedback from the air, as well as we'll have to drill a hole onto the oil gun side, so we have pressure sensor there. But besides that, yeah, this is what I have been able to do. And the next thing will be those things, which are the MOSFET controllers. Those will be housed onto this as well, and then we'll continue the work from here. So yeah, that's it for this week. Thank you for watching. Do the hard work, especially when you don't feel like it.